Good morning, second period. We are going to be on the same learning target from yesterday, which was I can solve systems of equations using substitution. Now, as you know, I gave you a few problems to try yesterday, numbers 8 through 13, and I have had some students so graciously volunteer to work problems, math problems, on camera. Summer and Sailor, go on up to the board. Go ahead and start working on your problems. We're getting number 8 and number 9. And if I can get volunteers to do another problem, we'll get some more problems put up there. Molly, your head's in it too. I don't know if you want to be on camera or not, but I just thought I'd better tell you. While these two people are working problems on the board, I'm going to go ahead and tell you what the answers to the other problems are. And maybe that'll give you the confidence boost you need to come up and work problems. Okay, number 8 and number 9 are coming up right now. Number 10, the correct answer, the solution, 2953, the ordered pair that makes that equation true, or where the lines would intersect would be 2953. Number 11, the answer -3, -11. The ordered pair that makes that system true. -3, -11, or it gives it the one solution. Number 12, the ordered pair that is the answer is 1, 1. Don't leave, you gotta explain it. And number 13, the correct answer is 1, 0. So if there's those of you who are sitting at your desk thinking, oh, I'd like to work one, but I don't know if it's right, now you know what the answers are, and I would be glad for you to go up and work a problem. All right, Summer, since Sailor is still working, I'm going to let you go ahead and explain your problem.
The equations was y equals 5x plus 1 and 4x plus y equals 10. And I just, since y equals 5x plus 1, I plugged it in to this problem, replacing y. And then I solved the equation, which got me x equals 1. Then I come over here and plugged in 1 with x, and then solved the equation, and I got 6.
Okay. So what does that solution mean for the problem?
That where it intersects is on the x-axis is 1 and on the y-axis is 6.
Not exactly on the axes.
But where it intersects.
Where the lines cross. Where the lines cross is at the point 1, 6. Thank you. That's good. Thank you. So for Summer's problem, the one solution that satisfies the system of equation is the ordered pair 1, 6. That means that's where the lines cross or intersect. That means that when I replace x with 1 in both equations and I replace y with 6 in both equations, I'm going to get the same thing on the left side and the right side of the equal sign. Okay, it looks like Sailor is ready now. So Sailor, go ahead.
Okay, well these are the two equations, and then you came down and you plugged in y. This is the answer for y, so I plugged it in down here. Or not the answer to the problem. So I worked it out, and you do this, you add 2x, and that becomes 6x plus 5 equals 17. And I subtracted 5 from each side, which would equal 6x equals 12. And you divide it by 6, and when you get the answer, it's x equals 12 over 6, which actually equals 2. Then, you come over here, you plug it in over here. So it'd be 2 times 2 plus y equals 17. And you multiply that equals 4 plus y equals 17. So you subtract 1 from each side, which equals y equals 13. So the solution is 213.
What does it mean for that to be the solution?
That's where
The lines intersect. Good. All right, thank you so much. Now that you have the answers, now that I've called out the answers to the problems, do I have any volunteers to work more problems on the board other than me go up and do all the talking?
not that bad.
It's not that bad, is it? Anybody? Just think at home, when you go home and your parents say, "What'd you do in class today?" "Miss Crumpton recorded me doing a problem on the board and put it on YouTube because I did so good." Can't you hear your parents? They're just going to burst with pride. Ugh. All right, so here's what I'm going to do. Since I've already given you the answers, if there is a problem that you need to see, since I can't get anybody to cooperate, if there is a problem that you need to see, please ask me now. Lift your papers. Please ask, and I will be glad to go through that problem for you. Yes, ma'am. Number 10. That was a popular one. How about if you call that out for me?
The first question was y equals 3x minus 24. The second one was y equals 2x minus 5.
Now, I want you to think back to the calling card problem from Monday. Our calling card problem, we had 2 equations, and we were trying to find the point where the companies were offering the same number of minutes for the same price. How did I go about, because this equation is set up in a similar manner. These equations, how did we go about solving those? We talked about it briefly yesterday morning. If I don't have a graphing calculator, what do I do? Look how they're solved. Hello? What do I do? 3x minus 34 equals 2x minus 5. Now, why can I do that? What are we looking at?
They both equal y.
Yeah, they both equal y. So by substitution, solving this by substitution, I can replace one of these y's with the equation, the rest of the equation. Okay, now what do I do? Solve it. Tell me how. Subtract 2x. Okay? When I subtract 2x, what do I get? X minus 34 equals -5. Now what? Okay? What does X equal? 29. Making sense? Okay. Questions or comments on what we've done so far? Alright, we've solved this and got a value for X. What do I do for Y? Doesn't matter. You got, which one did you like better, Mom?
3x minus 34.
So y equals what? What do I get? What's this? So the ordered pair, what does that mean? That's where these two lines intersect. If I were looking at their graph, that's where the two lines would intersect. That means that I can replace 29 in for x, substitute 29 for x, and I can substitute 53 for y. And if I worked this out, I'm going to get the same thing on both sides of the equal sign for both equations. Okay? Again, point of intersection for these two lines. Questions or comments? Anything at all? Is there another problem that you need to see? 13. 13 was a popular problem too in first period. Okay, so number 13, call it out to me. Equals what? Negative 1. Okay, I've got to solve one of these for a variable. Which one? Which one's easiest to solve for either x or y? Solve this one? What do you want to solve it for? Solve for x. How? Subtract 2y. I'm good with that.
And that will give you x equals -1 minus 2y.
Okay? Now what?
Get into the bottom.
Plug it into which one?
The first one
First one. Okay, so tell me how.
would be 3 times, or -1 minus 2y plus 4y equals -3.
Okay, now what? What property do I need to use first? Distributive. Tell me how.
Hug everybody now.
Hug everybody. How do I want to hug them?
Multiply.
Multiply. Tell me what I get when I multiply. Huh?
-3
-3.
minus x.
Okay.
So x.
Now what? Keep going.
-3 minus 6y. 6y plus 4y
Yeah.
equals 10y.
Are you sure?
Maybe.
Look at the signs again. -2y.
Yeah.
Okay.
Add 3 to both sides.
Add 3 to both sides. Plus 3, plus 3. And I'm going to come up here because I'm getting low on the board. So I got -2y equals what? 0. Then what do I do? Not add. Divide by -2. So what does y equal?
0.
That's half the story. Half of my ordered pair. What do I do now?
Plug the 0 into the second equation.
Plug 0 into the second equation. Have y'all got this where I can erase? Okay. Sure? Everybody good? I'm writing bigger, so, because that's the one thing I noticed yesterday's recordings, I had written too small on the board. Okay, so I'm going with the this equation?
Mm-hmm.
Okay, so x plus 2 times 0 equals negative 1. What do I do? 0. So x equals,
No. X equals -1. Sorry.
my ordered pair is
Negative.
negative 1, 0.
I did a step in between that.
Hmm?
I did a step in between. I did a step.
It's okay if you did a step in between, so long as you got x equals negative 1.
Okay. I did a step.
I'm good if you put extra steps in there, so long as we end up with the right answer and you're thinking correctly. Yes, ma'am.
How do you know which equation to do?
That is a good question, and it's your choice. It's your choice. You just pick the one. I always like to pick the one that's got the less numbers with it. Like this one, the coefficient's 1. Here I've got coefficients all over the place. So I would go, once I get that once I get one of the variables solved, I'm going to go with the easiest looking equation. If I were going to solve a literal equation, I'd go with the one that looked the easiest. Does that make sense, or have I just gone kind of?
That makes sense.
Any other questions? Yes, sir. Number 12. Number 12. Would you call it out to me, please?
2x plus y equals 3.
Okay.
Then 4x plus 4y equals 8.
Okay. Don't have an equation solved for one of the variables. So, do y'all see one that it looks like it would be pretty easy to solve for? The first one. What do I want to solve it for? Solve for y. Okay, so I got 2x plus y equals 3. How do I solve it for y? Okay? Then what? Come on. What? I heard somebody. It's right. Say it. I sound like Twilight maybe. Say it, vampire.
3 minus negative 2.
Okay? Now I've got us an equation. Now we can work with this. Substitute how, where, what. Tell me. Come on, y'all wake up.
For y.
Okay, where do I want to plug the y?
Yeah, 4x plus 4y.
Here? 4x plus 4 times 3 minus 2x equals 8. Now what? Distributive property, tell me how to distribute.
Hug your name.
Hug everybody in the house, tell me how to hug everybody.
Multiply.
Multiply them, tell me what I get.
4 times
12.
3 equals 12 minus 8. 8.
Okay, now what?
Yeah, the 4x and the 8x.
I can do that too. 4x minus 8x is what? And Lily up here told me to subtract 12 from both sides. So 8 minus 12 is what? So when I divide this, I'm getting so low down here. What does x equal? 1. Why is it positive 1? Correct. Negative divided by negative here is a positive. You're correct. Okay, now that I know that x is 1, what do I do?
Solve for y.
Solve for y, how?
You plug in
The one.
1 with
Plug it in where?
on the other equation with x,
This one?
the second one.
Second one? Okay. 4 times 1 plus 4y equals 8. Now what?
Yeah,
Solve.
equals 4.
Solve it how?
4 times 4.
Okay.
Give me 8.
Whoop.
What?
Am I doing this right?
Yeah.
Y equals what? Wake up, wake up, wake up. Second period is so quiet today. Y'all are never this quiet.
Wouldn't y equal 0?
Why would y equal 0?
Because I'm lost, and I don't know.
Tell me where you're lost. Tell me what I can do to help you.
I thought that I was the number line is that 4 times the y is 0.
4 times
I meant
y.
4 times, like if y was 0
Uh-huh.
and you plugged it in, it'd be 4 times 0 and that would equal 0.
Okay,
So that wouldn't work.
okay. I think here might be,
Oh, I know what I know.
you know what you did.
Yeah,
You sure?
yeah, I'm positive.
Okay. Anybody else? Questions? I think we've covered these pretty well. If you still don't understand something, I'd suggest you rewind the video when you get home, because you'll have access to it too. I would suggest you go back over these problems if you're still having questions. Okay? Then bring your questions to me in class, outside of class, whenever, so that we can touch base and make sure that you understand how to find the solution to a system of equations using the substitution method. I want to pose another problem to you.
Can we mark number 11? It's the last one.
Number 11. Yeah, we can work it real quick. Call it out to me.
Okay. Y equals 3x minus 2.
Uh-huh.
And y equals 2x times 5.
Okay, now this is again like the calling card problem. What do I do?
You put the equations where they equal each other.
Didn't we work this one?
We worked this one.
Okay. Put them equal to each other. 3x minus 2 equals 2x minus 5. How about if I do this? How about if I speed work this problem and see if you can follow me? And then I'm going to let somebody else explain what I did. Y'all want to do that? I've not done that in a while. All right. Ooh, leave 2 lines. Make sure. Okay, then. Okay. Did I get it right? Yes, I got it right.
Well,
Who can explain it?
it takes me that long just to write down the columns, so.
What did I do?
I didn't get that answer.
You didn't get that answer. Who can follow what I did?
You subtracted 2.
You went ahead and done it where you didn't have to do it 3 different times.
Yeah, okay. Right here, I did something right here.
No, you had it too.
I did something right there. I did 2 things in one step.
I know that messed me up.
That messed you up.
That scared me. I was like,
I ain't ready for that.
You don't have to. You don't have to do it this way. You can add a step. You can add a step. Here where I added 2 first, you could bring down the 3x. Bring down equals 2x minus 3. And then you could do that step separately where you subtract 2x from both sides. Okay? You okay back there?
Yeah.
You sure? You're not gonna fall out. Don't you wanna come up here? Your mama would be so excited.
No, she wouldn't.
She posted
She
something
wouldn't
on
care.
Twitter about it.
What?
Mama posted something on Twitter.
Okay, anything else?
No, she wouldn't.
We good?
She was like so proud of my little girls on TV. I'm kidding. I'm on YouTube. I'm already on
Alright,
YouTube.
is there anybody who does not have a clue how I got the answer to this? Okay, again, I worked that in super fast mode.
I know.
How many times did you practice doing it like that?
Once or twice. Actually, it's my first time to ever work it wrong, if I'm gonna say that.
What the heck?
I'm just kidding.
Well, it takes me that long to write down the problem, so.
Hey, listen, I like it when you're slow and cautious. I just did that one quickly so we could get something else in for today. We are still on solving a system of linear equations using the substitution method, but I want to give you a problem and I want to see what happens when you try to work this. 2x plus 3y equals 4. And 4x plus 6y equals 9. Alright. So let's think about it a minute. Let's think about what we got. Do I have one of these equations solved for either x or y? No. So what do you want to do? What are we going to do with it? I don't know. Well, that's not the right answer.
I don't know. We're gonna solve one of them.
We're going to solve one of them for either x or y. Which one do you want to go with?
X. X is my first.
The top one.
The top one. Okay, what do you want to solve it for?
X.
Okay, so we got 2x plus 3y equals 4. Tell me how to solve it for x. Subtract 3y. What do I have after I subtract 3y?
2x equals 4 minus 3y.
Okay, then what?
You divide by 2.
Now, something that I want to call your attention to right here. When I've given you literal equations on the 5-minute quiz and I've asked you to solve, some of you are doing this. You're making a big, long fraction bar underneath the whole problem on the other side. And you're putting that 2 and you're leaving it. You can't do that. Here's what I need you to do. I need you to divide each term separately. I need you to put that fraction bar under each term separately, okay? So we've got x equals, what's 4 divided by 2? Negative 3 over 2y. Oh, I know y'all love that one with that fraction in there. I can see the love. I can feel the love. So now that I know that x equals, that looks like a crazy 2. X equals 2 minus 3 halves of y. Tell me, what do I do? Plug it in there. Second equation. So 4 times 2 minus 3 over 2y plus 6y equals 9. One of y'all that's close to the back, check and make sure that we're getting that much of the board. Okay, it's picking up this over here too? Okay. I just want to make sure. Thank you. Alright, now what do I do? Distributive property. Tell me how. Hug everybody. What do I do when I hug everybody? Multiply. 4 times 2 is? Now, I need you working on fractions. That's why I've given you some fraction problems the last few months. Because I need you proficient with fractions. 4 times, I'm going to ignore sign, I'm going to ignore a variable. 3 over 2. It's what? 12 over 2, which reduces to? 6 over 1, which reduces to? 6.
Oh girl. Oh girl.
Now what?
6y plus 6y.
Negative 6y plus 6y is what? 0. So that's 0. I've got 8 equals 9. 8 equals 9? Huh?
Find something they both go into.
Is this true?
No.
This is a lie. A bold-faced lie. This problem is lying to us. Guess what? Can't work this problem. There is no solution. Now, if you've got your math book, I want you to turn back for me to page 335. I want you to look at page 335, and I want you to look at the bottom of the page at the 3 graphs given to you. Is there one of those graphs that has no solution?
Yes.
Yes. This would be called an inconsistent system.
The lines are parallel.
This is an inconsistent system. The lines, as you said, are parallel. If I graphed these 2 lines, they would be parallel. Their slopes would be the same. Their y-intercepts would be different. Okay? These lines will never, ever, ever cross because they're parallel. That means there is no solution. There is no ordered pair on the face of the earth that is going to make this system have a solution. It is an inconsistent system with no solution. You're not going to find that perfect little ordered pair answer. Okay? Now, I need to make sure you understand no solution and what no solution means. Okay? No solution means they're not an answer, you're going to get a lie.
That lie right there.
This problem just lied like a dog.
Oh my god. I lied to me.
It lied to you. Don't you feel brokenhearted?
Yes.
All right.
What's the dirty?
Has everybody got this written down? Quit. Everybody got this written down? Yes. Okay. Now, I want us to do one more problem. One more problem. I got one less problem. After this, I got one less problem.
That one mess right there, God, bro.
Now we're going to get into copyright. Okay. Now, what do you want to do with this?
Solve it.
How?
Okay.
Yes. Which one do we want to solve for the other one?
The top one.
The top one? Okay.
For X.
But wait,
You can't solve
we did the second one, wouldn't it be easier to get an answer for the top one?
because the top one doesn't have any numbers except for the one. Like, they're really hard.
I think I see what Sailor's seeing. Sailor sees this variable's already over here by itself. If I go with this one, I've got two variables on the same side. I mean, either way you go, it's only going to be one step. Alright? So, it doesn't matter to me. Take a vote. Who wants to solve this one? Two people. Who wants to solve this one? More people. Okay, so let's solve this one. Tell me how. Divide everything by 3. Divide each term separately by 3.
So that would equal
X equals Y plus 1.
Sailor said something there. How do you see it as they equal the same thing?
well, at first I thought that, but I don't know. I didn't mean to say
I
that.
think you're onto something now. I really do think you're onto something. Lily's looking at it too. Lily's, I think you and Lily's got the ESP thing going here. Alright, let's keep going. Let's keep going and see what happens. Now I know that X equals this. What do I do?
You put Y plus 1.
Y
Plus 1.
plus 1. Oops, that's not
Get my back.
right.
Oh,
Y plus 1 minus Y equals 1. So what happens? Say it again. Add Y minus Y, and what do I get? 0. So I've got 1 equals 1. Ha!
Hey,
That one's true.
that's
This one,
true.
this one didn't lie.
It
This
is
one didn't lie. Guess what? Now, if you still got your book out, I want you to go back to that page that I referenced a minute ago, page 335, and I want you to look at that middle graph. I want you to look at the middle graph. This solution, if I graphed these two equations, would have the exact same line. There would be no difference. Put them both on the graph, ain't nary a difference. They are the same line. That means that whatever ordered pair you choose from that line, as long as that ordered pair is on that line, that is the solution for the system. There are infinitely many solutions. Now, you're gonna put it on there and see? Okay. Now, I think what Sailor and Lily were saying just a second ago, when we got right here, looking at these two equations together, if I solved this one is in standard form, ax plus by equals c. If I solve this one for standard form, I'd have the same thing. And y'all were kind of seeing it, I think. Make sense? This is consistent and dependent. With infinitely many solutions. Infinitely many solutions. Okay? Now, I want to make sure that you understand the difference between no solution and infinitely many solutions. So I want you to work problems 14 and 15 off of page 347. I'm sorry, not 14 and 15. I want you to do 15 and 16. Okay? 15 and 16, page 347. Those of you who are sick at home and watching, hope you feel better soon. Did I figure out your test?